We are asked to fully factor this quartic function, p of x equals 2x to the 4 minus 15x cubed plus 34x squared minus 15x minus 18. We need to determine a value for x that will make this quartic function equal to 0. And that can be done through the process of trial and error. The way we decrease the range of numbers that we use to substitute into the function to make it equal to 0 is by using the rational roots test. This is done by taking all of the factors of the constant term, which in this case is negative 18, and trying both the positive and negative factors of it, of which there is positive and negative 1, 2, 3, 6, 9, and obviously 18. I will start by subbing in 1 into the equation. When we substitute 1 into p of x, that does not give us the desired result, as it results in negative 12. So let's start another number. Let's try negative 1. When we substitute negative 1 instead of x, we get the result of 48. Once again, not the desired number we are looking for. Let's try a number higher. When we substitute 2 into the equation, it gives us the desired result of 0. Therefore, x minus 2 is a factor. Guessing these numbers can prove to be tedious, but once we find a value of x which makes the equation equal to 0, we can continue with finding the roots. So, once we've found a factor, we can use either long division or synthetic division to reduce the quartic function into a cubic. When we do so, we are left with the remainder 0. This quartic function reduces into a cubic of 2x to the third minus 11x squared plus 12x plus 9. Now we have to use the same process to determine the factor of the cubic. We can try and use x equals 2 again, seeing as occasionally it will serve as a factor more than once. When we substitute 2 instead of x, we result in 5. Therefore, p of 2 is not a factor. Let's try a number higher, p of 3. When we substitute 3 into the equation, we get 0. Therefore, x minus 3 is a factor. Because this cubic equals to 0, when we use the root 3, x equals 3 is a factor, and we can use it to turn this cubic into a quadratic equation through the use of synthetic division, or long division, whatever you prefer. When we divide x minus 3 by our cubic function, we are left with 2x squared minus 5x minus 3. Once we get to this point, we can use regular factoring to determine the roots. So we need to find two numbers that multiply to negative 6 and add to negative 5, of which are negative 6 and positive 1. Once we factor this equation, we result in 2x plus 1 and x minus 3. And overall, these are our roots: 2x plus 1, x minus 3, and x minus 2. When we expand the equation out, we should result in the quartic.